everybody. Welcome to the Kimberly Cloud Show. I'm your host, Kimberly Cloud. I have a very special guest here for the show today. Can you go ahead and announce to the world who you are and where you're calling from?
I'm Ron Voller, and I'm a writer based in New York City.
Okay, and we had a lovely conversation before the show, but I would like to know, can you tell me about your past, extensive history leading up into your present?
Sure. Uh, yeah, I guess we all have one if we get old enough. I was born and raised in a kind of a family of diverse interests, and outside of Chicago, Illinois, as a matter of fact. Go Cubs. And yeah, I was, as I said, a very diverse, very curious family. My parents are both in the music business, which is my second love. You can see the instruments behind me. I also write. I'm a songwriter, and kind of grew up in that world. My mom was a song and dance gal. My dad was a Dixieland jazz drummer on nights when he wasn't running the family business. And I sort of grew up in that world. So I began writing about the time I began writing. And I did other things. We used to do skits. My brothers and I would do skits for the family on special occasions. And I directed my first film when I was 11 at the family business, my brother crashing out of the thing into a heap of foam that we had stored, and, whatever fun we could get into and tell stories and begin the process, I guess, of figuring out who I was as a storyteller. I hold storytelling as a kind of the core of human evolution, and one of the core traits that has helped us grow as people. And so I guess I've just always gravitated to it. I went to school. I went to the University of Denver and graduated there with a BA in music and literature, staying true to me, and didn't ignore the verbal lashings from mom and dad about having something more substantive to fall back on. And just have basically persevered in making myself. I started with a music career out of college, and then decided to try after some success in that area, in the Denver area. I moved to New York and decided to try writing, and that's kind of what I've been doing for the last 20 plus years, writing and researching. And of course, I found Milton Humason, this astronomer of just out of nowhere, who came out of nowhere to become one of the great observers of the 20th century. And that has taken me on a journey I never could have expected.
Speaking of him, tell me a little bit about what you wrote about him, and then I'll ask you questions from there. And then we're going to go into the Big Bang and every other book and every other thing you researched.
Sure. Yeah, Milton Humason was in 1917, was a janitor at this new observatory that was built. He helped to build as a cowboy and a pack mule train driver, hauling materials and men up this 10-mile trail to the summit of Mount Wilson outside of Pasadena, California. And later he became a janitor in 1917, just after this big telescope had been built. It was the biggest one in the world, 100-inch telescope, 100-inch primary mirror, over 8 feet wide, huge thing, thousands of pounds of glass. And about 5 years later, through several of his friends around the observatory befriending him and teaching him some of the skills of photographing the starlight, he realized this new vision of his to become an astronomer.
What year was this?
So he became an astronomer in 1922.
So this telescope that they built back in that era, how far could it see out? Could it actually, like what could it see from Earth?
Yeah, that's a good question, because I think, we talk about people observing things that are most of the stuff that a guy like Milton Humason was observing, Kimberly, you couldn't see even through the telescope. I mean, just with your eyes. Most of the stuff you see in the sky is just stars. They're in our galaxy. They're actually pretty close to our galaxy. If you're fortunate enough to live in a dark enough place where you can see the Milky Way, you're actually looking at the center of the galaxy. And that outline is kind of the shape of our galaxy, as it turns out. All of this was being discovered at places like Mount Wilson through the 1910s and 20s. And
How
Milton,
did they know that the Milky Way was the center of the galaxy? You just taught me something new.
yeah, you're kind of looking into the center of the galaxy. That was determined over really not just, it was kind of centuries in the making as people were discovering new things about how to analyze starlight. We developed ways to measure it and measure distances. And so we could start to measure how far things were apart. And it was actually a colleague, a champion of Milton Humason's, a guy named Harlow Shapley, who in 1918 came out with this idea that the Milky Way was enormous, 3 times the size it actually is, he thought. He thought it was 300,000 light years across, actually 100,000 light years across. But he believed that the entire universe was encompassed in the Milky Way. And there was a big debate about it in 1920. And later, this guy, Edwin Hubble, that everybody knows about, who has his own space telescope, discovered a way to measure a galaxy far enough out that there's no way it could have been in Shapley's galaxy. And that's the farthest we can see from Earth. 2.5 million light years is a place called Andromeda. Everybody's heard about Andromeda. Hubble discovered that Andromeda was really much farther away. And that sort of started to open up the universe.
Was this through the telescope that they were able to measure in 1922?
That's correct. So in 1921, Milton Humason is not yet in, this is the extraordinary thing. This guy he was, as I said, a cowboy. He was a poker player. He was a moonshiner. This was in the Prohibition era. He was a rancher, a cowboy, just this kind of old school mountain man figure that everybody loved, probably in part because he wasn't anything like the guys who did the research at the observatory. In 1921, he's not yet an astronomer. 10 years later, in 1931, he's standing, having his picture taken with Albert Einstein in the Hale Library at the observatories, having just convinced Einstein that he was wrong and that the universe was actually expanding. Einstein couldn't believe that, and Hubble and Humason proved him wrong. 10 years, meteoric rise. Excuse the pun.
It is well said, well said. And I would assume that the universe is expanding because the universe to me, you got the universe, multiverse, and omniverse, but it reminds me of a woman having a child. Every day a planet is being born and a star is being born, if not sooner. So why not can it be born? I mean, yeah.
I love that. It's a really wonderful analogy, I believe. And there's not, we don't actually, science hasn't figured out certain things. 2 of the big ones, right here at home is one of them. We don't know why life began on Earth. We're not, the science anyway, has not figured out why life began on Earth. Likewise, we don't know why the universe suddenly began to expand. And that's why I think other options like a multiverse, omniverse are out there as a kind of possibility that, hey, if this could happen once, it could happen a multitude of times. Why should this be the only universe necessarily? That's been sort of figured out theoretically as well. And so, but getting to where we can really prove things like that, it took hundreds of years of development in astronomy and understanding how gases work and discovery and et cetera, for us to even get to the Big Bang. So you can imagine a multiverse, discovering how, even figuring out how to discover whether there's a multitude of universes is a very, very complicated mess. It's not first on the agenda. The first thing is to figure out, let's go back to the actual beginning, which we haven't got to yet.
That is so well said. And you know what else? Like, our sun is starting to fizzle out. Not right now, but in a couple of million years, it's going to fizzle out. So my theory was to go to a different planet that's a dormant planet that doesn't house any life,
Mm-hmm.
and sit up there, and it has an extra sun or an extra moon, and you kind of like zap that into something, or zap the energy source from it,
Mm-hmm.
and put it where Earth is. Now, China has its own sun that is powerful than the sun we have in the laboratory. So what are your thoughts on having a sun? Because obviously we know through China we can build our own sun, but in energy. But what about doing it another way, by getting a sun from a different dormant planet that's not housed with life?
It's a much more feasible accomplishment. Yeah, China's basically replicated the processes. But a sun, that would be an immense thing. The sun is 1 million miles across. It's an incredibly large star. It's actually a kind of a mediocre star as stars go. Betelgeuse is 300 times the size of moon of our sun.
What's a Betelgeuse?
Betelgeuse is the red star in the constellation Orion. If you look up at night and you look at above the Orion's belt, up at the top of Betelgeuse, you'll see a red star there. Or sorry, at the top of Orion, you'll see a red star there. That's Betelgeuse, and it's a popular star. It's a red giant star. It's a massive, massive star. But our star, it'll be billions of years before our star finally fizzles out. But I think that's where science is heading. It is in the direction first of figuring out, they call it terraforming, how to terraform a planet or a satellite to a planet. Some of the moons of Jupiter, for instance, and Titan are candidates in our world. And we need to start there, mostly because it's really hard to get anywhere else. The nearest stellar system to our solar system solar system to our solar system is about 8 years away at the speed of light. So you can imagine, at the speed of light is 6.5 trillion miles a year. It's really, really fast, 186,000 miles a second. Really, really fast. And it would take us 8 years to get there at that speed, and we can't travel at anything like that speed. So it's really hard to assume at this point, at this stage, that we can do that. However, modern research in planetary exoplanets, everybody's heard of these days, that's one of those outlying ideas, is what's out there that could be habitable. What Earth-like planets are out there? And we're starting to try to understand how, if our assumptions about where Earth is from our star hold true in other worlds. There's this thing called a habitable zone that the Earth is in. And we're the right distance from the sun, that our atmosphere doesn't get wicked away by its powerful solar winds. We're in a steady orbit. The tilt is right, so we get the seasons. There's, just these. Are these the optimal forces that create the conditions for life? Again, we don't know why life began. Seems like the conditions were right, because we certainly have a whole lot of life on Earth. So, we're just really, really scratching the surface of planetary expeditions. Living on Mars today would be the highest form of cabin fever. You can never go outside. Even if you go outside, you're inside. So feeling the wind on your face, no trees, that's why in the Star Trek, in the space series, you see holodecks and people can commune with nature because there's no nature where they are. So anyway,
You know, how they got underground stuff, possibly. So why not? I don't know, because Mars have water, but maybe we could like build something underground where it's possibly, if it's water underground, then like build trees and have a whole oxygen type thing. What do you think? Is it plausible?
well, we don't know how much water there is on Mars yet. This is key because you need water to create life. The idea of terraforming Mars or any other solar satellite is a hundreds of years, if not 1,000 years, undertaking. We're not good at it. You've seen stuff bouncing and crashing off of the even the moon these days. I'm sure you saw the face plant. It's really hard to do this stuff. It's very far away. The signal to make commands of an object in space takes half an hour at some points from here to Mars to go through. So we send the signal and then it happens a little while later. You just can't do anything fast unless you're on the ground there. And that's why I think there's this push to get people to Mars in a way where they can actually explore and start to live in those conditions and push things around themselves and come back with knowledge of what that is. So I think that's going to be the next phase of operations. But we're talking about something, Kimberly, that's quite a ways out. These things just aren't going to get done quickly, mostly because it's really hard to get there. We have a hard time getting off Earth and into space. It's really hard.
I agree. And I have two more questions for you before we close out. Okay, we're going to talk about Albert Einstein's E equal MC squared. It was a short condensed version of a long, equation. And what I wanted to know was, did it have anything to do with outer space, or was it just math, pure math? What kind of math was it?
Great question. Theoretical physics. I will sum this up for your audience rather than getting too in the weeds. But yes, the equation E equals mc squared, which was not its original. Those weren't the original variables given, but anyway, that's what we ended up with, and it's very elegant. Is the result of a lot of analysis and mathematical analysis. But this is such a good question because it really gets to the heart of what Einstein was doing. Like any mathematician, including Newton, who put forth all of those ideas about objects in motion and gravity. And, he was the one that really kind of sprung things loose. He and a guy named Huygens. They really got the ball rolling. What Einstein did with E equals mc squared was he brought light and other forms of energy into the same focus. And he basically said that he equated light with gravity in a way that, so we're talking about space now, large objects in space, because of their gravitational influence on the fabric of space. Space is more like an ocean than a river, but okay, the fabric of space, right? We can get a sense of what that is. They make an impression in that fabric such that if there's a star behind the sun, for instance, right, you couldn't see it because the sun's in the way. But in an eclipse, and this is one of the ways that they measured, or they proved Einstein correct. In an eclipse, you might see that star's light. You could see the star, even though it's behind the sun, because its light is actually bent around the sun. That's the gravity of the sun, its impact on the fabric of space. And the Earth has a little too. There's a gravitational center between the Earth and the sun, et cetera, et cetera. All of the planets and the planets to their satellites, the moon and the Earth have a gravitational center as well, a thing that keeps them in line with one another, basically. So that's kind of where that's where Einstein was going with E equals mc squared. And it was later started in 1907, but for the next 10 years, he started to develop this idea that really bringing gravity into the equation in a new way. And that's what general relativity is all about.
It's so many questions I would love to ask you, but the last question is this. I want you back on, before I go into the question, I want you back on the show for a part 2, because you have a lot to offer my audience with knowledge. And I wanted to sway in to something that may, it's not going to make you feel uncomfortable, but you may not know about, but I'm pretty sure you do. Have you heard of the Neuralink with Elon Musk?
Yes.
Does that, what do you think when he says, how do you feel about it? Number one, that's the last question.
I mean, it's this. I think that belongs in the realm of things we haven't yet really proven to exist or not exist. It's not out of the realm of possibility. It's one of these questions that still needs to be answered, and I think people are come up with a lot of different ideas. How we're wired and how the universe is wired to us. Yeah.
Do you think that, I have to say this, do you think the universe is all connected, like spiritually, and what is the good word? Not, well, with, because you know, a planet is born out of nowhere. You're like, how did that planet, why would this planet be born out of nothing? You know, it has to be some type of habitable space type force that it says, hey, look, this is the perfect spot, like a Goldilocks spot. You know, I don't know much, but then you got the universe as a whole. Like, I think it's electricity, you know, plays a key factor in a lot of, because they have different types of energy sources. Like I've heard them talk about Earth 2. They said that there's a possibly habitable life, but this energy source have a core inside of it it's bigger, so it's not quite like Earth 1, which is our Earth. You know, what is your input on that?
Wow, such a good question. We could talk all afternoon just about this subject, and it happens to be something that I'm really wired into personally. Although, again, we don't know all the answers. But you raised you raised a metaphor earlier about womanhood, about birth giving, right? So when we develop in the womb, as we have seen, I think it's been proven pretty without doubt, because we sort of come apart and become ourselves out of this kind of bean shape that we are, there are connection points in our being where we have reflexive. You've had your shoulders massaged and felt a twinge in your finger before and things like that. There's this connectivity to us, as we're not luminescent In other words, if the sun went out today, we wouldn't be able to see each other because we were glowing, but we are made of atoms. And those, I know it sounds funny to say, but we are made of, because, you know, guys like Yoda in the movies talk about this. Luminous creatures are we, not this crude matter. Well, we're crude matter, but that matter's not very crude. It's actually, all of it is kind of a chemical energy. And what I will say about the universe is, and Einstein said this, Carl Sagan said this, and more recently I've heard guys like Brian Cox, astrophysicists, you know, Neil deGrasse Tyson's another case, and they talk about the idea that we're atoms. Everything on this planet, including the planet itself, made up of these atoms, and some of them are as old as time. Hydrogen, it's been around since the beginning, very nearly the beginning, and then some newer stuff that's been created by our sun through the fusion process. It's created things like iron and so forth, and those bits help to create the Earth, which is basically a molten hunk of iron ore, rotating around orbiting the sun. But we hear this, what's amazing about this is we orbit a relatively minor star in an average, maybe a little above average galaxy, which is one of 1 trillion or 2 trillion galaxies in a universe that is at present about 27 billion light years across. The idea that it's the only one where a sentient, intelligent being could be born feels to me odd. I think that there probably are. What they look like or what their home looks like is probably a little different, but it's pretty unique that, for as far as we know, this is the only place in the universe, the known universe, where those atoms, primordial atoms and the newer ones, have come together to create a species that through the universe can conduct research. And it's actually kind of a way for the universe to reflect and think about itself. And that's a beautiful thought. I love the thought that we're all part of this universal language, and and there's way fewer of us living on Earth than could have been born. So we have really a unique chance to spend some time learning about the world we live in and the broader universe that's made it possible, because it's a real chance that we got to where we are. I could do a whole program with you about how hard, how rare, how many different things happen in the cataclysms that happened since the beginning, that somehow in this part of the remote universe we exist, is really amazing, truly amazing.
You know what I say? Don't laugh or get mad, but I say that we must be on the west side of the galaxy because everybody's fighting all the time.
Yeah.
You know, what the bigger picture is this: instead of fighting, we need to come together and figure out a way, because, like, in the future, probably outside of my age, there is going to be people, advanced civilizations that come there, and my point is this: we have civilizations that's possibly behind us 300, 500 years. We have civilizations that's in front of us 500 to 1,000 years. If we go probing on the wrong, planet, there could be a war that triggers, and there's could be a secret clause that say you come to Earth, you have to obey Earth rules. But some people isn't going to take that ever so lightly. That's more advanced than us.
Yeah.
What is your input on that?
Yeah. Well, my first input is that I doubt very strongly that we'll ever be visited by strangers from another planet for the reasons I gave earlier. It's very far, and just even detecting our signal. I mean, if they're across the galaxy from us, the signals we sent out 70 years ago won't arrive for another 20 or 30,000 years. So, I mean, it's a very difficult thing to even think about. But yeah, I don't disagree. I think my personal belief is that wage peace is the right way to go. Fight fire with water, here on Earth, the very earthly, the existential problems that we have, which are very real. 6,000 years of civilization, still haven't domesticated the human species, but we're working on it, and we have made some improvements. It's just a very, very slow process. But I think you're absolutely right. You don't know who you're going to meet when you get there. If you watch or have seen shows like Star Trek or seen the movies, the whole idea there, the principle was check things out, but don't get involved. That would be that's a progressive, if you want a progressive way of looking at space travel. That's not who we have proven ourselves to be here on Earth, at least as we, go into other people's territories and take them over and pretty much just tell them their way was wrong. So you hope, though, that if we were to find another planet with a species on it that was intelligent and had created its own culture, et cetera, and had a global civilization going, that we would not impede. And if we were to get in contact with them, that we would not try to take that civilization over. But this is where you get into stresses, right? If we were visited by a group who were desperate because their planet was being eaten alive by their home star, for instance, they might not take, peace for an answer. And so there's a lot of different equations. It's hard enough to get humanity on the same track. I hate to try to do it for all of alien life at the same time. I'm not sure we can. We might come close to solving the world's problems on your show, Kimberly, but I don't know about the rest of the universe. We should. I'm kidding, of course. But yeah.
Last question, I'll put this on God.
Sure.
What is Albert Einstein input on the way the world should be functioning with war, if he even had something to say about it?
Sure.
What was his input?
Oh, he was a pacifist. He was definitely a peace guy. He was like me, wage peace. He, of course, underwrote the making of the atomic bomb, but only because he was convinced by others that Germany was building one. And in fact, they were right about that. But after the bombs fell on Nagasaki and Hiroshima, he definitely felt like it was a horrible decision to have to make to even get behind such a thing. I think most of us in the world, I really do believe that most of the people of the world do want to live in harmony. They want to have their family and friends, be able to speak to strangers without fear of aggression, or I do think that I feel that across political spectrums, whatever you have. I've met with a lot of people all around the world, and what I see mostly are just, pleasant people trying to make their way in life, whether it's in some of the, more up and coming countries or the European countries here in the West. I think it's, I don't think that people are very different from each other in that particular sense.
Okay, I'm gonna let you go with this. Where do you see yourself with the knowledge that you have going for the future? That's what I ask all my clients at the end.
I appreciate that. Well, I have a podcast called Bang Goes the Universe, where I talk about the developments in human culture that led to Western philosophy and science and to the Big Bang, and the people involved in that discovery. That will probably culminate in my third book on Big Bang expansion. Uh, so I'll be, I have writing in my future, that and other topics. I'll probably do some more producing. I'm currently producing a documentary film. I like to work in the documentary film space, so I see myself doing more of that. And I'll probably get back into children's fiction, which is where I started about way back in 2004. I wrote and illustrated my first children's book, and I just kind of left that while I've pursued this course of the Big Bang. So I'm probably just a lot more writing and speaking and trying to encourage people to do the same. I'm a big believer in storytelling. I think it's what sets us apart as a species here on Earth. I think self-expression is a big part of why we have come to where we have come to, and I encourage people to tell their stories. You don't have to become Joan Collins or Patterson or Chernow or any of the other writers. You don't have to become Spielberg. You don't, but get involved in expressing the world through yourself. That's been my game all along. And that's what I will pursue for the foreseeable future.
Talk about talking in 1.5 bits. Yeah, pretty cool. So, how can the people reach you?
You can get me on my website, ronvoller.com. Pretty easy. That has links to all my social media, my podcast, my books, people I've talked to and met with, and the places I've been. That's probably the easiest way. Just go to ronvoller.com.
Stay on the line. Thank you so much, everybody, for joining my show today. You take care, be safe, and I'll see y'all next time. Stay on the line.